Hi Year 12s, I'm going to go through question 6 from the January assessment. Okay, so this is split into 3 parts with small amounts of marks but actually a reasonable amount of work for them. Okay, so the first part is a find, so you just have to find the answers. Find the x values of the stationary points of the curve y equals 2x to the 4 minus x squared. Well, I like to know what's going on, so I'm going to sketch that graph. So we've got y is 2x to the 4 minus x squared, squared. Okay, I'm going to draw that. Right, I can see that it's looking a bit midget at the minute, so I'm going to zoom in. Okay, I'm going to draw a little box around it because I want to see what's going on there at the axis. Looks like the exciting things are happening there. So I've just did zoom and then box, and then you click on one corner and then you move your arrows to make a little box and press execute when you're happy. Okay, that's better. Now I can see my stationary points, and in fact I could answer the question by simply pressing G-solve. Okay, and then I want to find out where's the maximum. It looks like it's at the origin. There we go, it's at the origin. Okay, and G-solve and minimum, and we get minus a half. So we just want the x values, and then if I press the arrow it'll give me the other one is positive a half. Okay, so I could just write that down, and because it says find, that would be accepted. However, I'm going to walk through how we do this. So stationary points are where the gradient is 0. Okay, not where the function is 0, that's roots. Okay, but where the gradient is 0, where it's a flat curve for just a moment. Okay, so that means that we need to do, if we've got y is 2x to the 4 minus x squared, we need to differentiate it to get the gradient. Okay, so that'll give us 8x cubed minus 2x, and we're interested in where the gradient is 0. Okay, so it's stationary, it's not increasing, it's not decreasing, it's stationary. And then we're going to solve this. So again, you could use your calculator to solve it, and indeed we have. Okay, but I'm going to do it by hand here, just in case you want to know how it works. Okay, so I factorised. So that means that either x is 0 or 4x squared is 1, which means x squared is a quarter, which means x is plus or minus a half. Okay, so we've answered the first question. We found the x values of the stationary points. Okay, let's look at part 2. So we want to know, determine. So this time we have to show working out. If it's a determine, it means that we have to explain, justify our solutions. Determine in each case whether the stationary point is a maximum or a minimum. So we can see on the graph, which is really helpful, isn't it? Okay, so if we notice for minimum points, we're going from a negative gradient to a positive gradient. So the gradient is increasing. So that means the gradient of the gradient is positive, if we're going from negative to positive. So here was dy by dx. Okay, so I'm going to find the second derivative, and I'm interested in whether this is positive or negative at each point. Okay, so if we differentiate, we get 24x squared minus 2. Okay, so we want to know what is this doing when x is 0 and when x is plus or minus a half. So let's do x is 0. Okay, so when x is 0, obviously we get 0, take away 2, so that's minus 2, that's less than 0. So that tells us the gradient is decreasing. It's going from positive to negative. So we're going from positive, which is uphill, to negative, which is downhill. Okay, so that means we have a maximum at x is 0. Okay, and then we want to find the second derivative, where x is, let's do minus a half. Okay, so in this case we've got 24 times minus a half squared, so we're going to get the same answer as positive a half. Okay, and that is going to equal, so let's say that's a quarter times 24 is 6, take away 2, so we'll get 4, so that's greater than 0. So we're increasing our gradient, so we're going from negative gradient to positive gradient. Okay, so that's a minimum at x is negative a half, and if we do the same, let me just move that up, where x is positive a half, then we're doing 24 times positive a half squared minus 2. That will give us exactly the same value, and so we get the same result. Okay, so we had to go to the pain of writing that out because the question said determine. Okay, right, so the final part of the question, let's just have a look. Hence, so using this, state the values of x for which the curve is a decreasing function. So remember, decreasing functions are going downhill. So I'm going to do myself a little sketch of the graph that we know we've got. Okay. Right, so we've figured out that we have a maximum at 0. Okay. And we've got minimum at minus a half, and we've got a minimum at a half. So that's from our answer to part 2, but also we know because we've looked at our the graph here. Okay, right, so decreasing function means it's going downhill. There we go. And this one is going downhill there. It's going uphill in between. Okay. Now, we can't include the minus a half because it's stationary there at 0. So this tells us that we have a decreasing curve to the left of negative a half, so x is less than minus a half. Notice we have to put the x first when we have a single inequality. Okay, and then in this little bit between the 0 maximum and the half minimum. So this time we've got a sandwich inequality from 0 to a half.